that if I'm talking and you talk, what everybody hears is an addition of my talking and your talking, so shut up. Okay. It also says that we can have light shining down from the ceiling, right? And the light shines down from the ceiling, but I can take my 10,000 watt carbon dioxide laser. I can turn it on, and that laser beam can shine across the room that way, and the light rays from the ceiling can shine down. And where they overlap, it would be a little bit brighter than the laser beam, and but they would just add together. But they don't like block. One wave doesn't block another wave. They just pass through each other. This is superposition. Okay? And when they pass through each other, we expect that they actually add up. So here is, I'll show you constructive interference. I'm going to send 2 up pulses. Watch what happens in the middle. Whoa! 2 up pulses add to a super up pulse. Yeah? Watch that. It's like, whoa! Do you see that, how they add up? It's even like more energy, right? Okay. Now, that's kind of fun. So that means that you can actually make constructive interference. In fact, these speakers are designed to be pushing out at the same time. So if you're equidistant from them, then you're going to hear them from both, and it'll be a little bit louder because it's like constructively interfering with that. Unless you hook them up wrong. A little story about that, right? Okay, so now I'm going to do the opposite. I'm going to send an up pulse from this side and a down pulse from this side. Watch what happens in the middle. Whoa. What is that? Do you see it like for an instant in time? It's like flat when they cross each other. Watch again. It's like, let's go. So constructive interference is up pulse meets up pulse, right? Going through the rod, right? It makes a giant up pulse, right? It's got to make that a little bigger. Whoa, I'm the big up pulse, right? Right, then these guys go this way, right? So they add up. This is constructive interference, right? Destructive interference is up pulse meets down pulse, right? And in the middle, it's possibly flat, right? And then, of course, the down pulse and up pulse are going on with their life. Now, if this makes sense, this is like the potential energy of both of them. Right? Well, where's the energy here? If for an instant it's like that, where'd the energy go?
Potential.
Well, this is potential where the medium is disturbed. Where did it go here? It's not potential, it's kinetic. Isn't it probably moving really fast? Like in this instant when it's flat, there's a piece of stuff that's going that way and a piece of stuff that's going that way. That's why it happens for such a short period of time. Watch. It's like, but here's the cool thing. Watch this time. Every time it does it, there's always one of these that doesn't move at all. Watch. If I do it just right. It was that one right there, wasn't it?
Yeah.
One of these doesn't move at all. So if this is like sound from outside, like the airplane or the jet or the classroom or something like that, usually it's better if it's a repetitive sound. And this is a little speaker that's sitting on your ear, and that's where your ear is. Doesn't your ear hear nothing or almost nothing? Yeah, so those noise cancellation headphones, what they do is they sample the incoming sound. They've got a little speaker, and it processes that sound, and it creates a pulse such that when it reaches your eardrum, both those pulses meet at your eardrum, and your eardrum does nothing. Isn't that wild? So and if you listen, if you put them on, at least the old ones, you turn them on, and it took a few seconds for it to figure it out. Right? It would sit there and go, calculating, and then the noise level would just go, yeah? Okay? Now, the funny thing is, if somebody talks, chances are, if they talk, you can hear that over that, right? So these noise-canceling headphones can do clever things. Like they can cancel out the noise of the paper machinery, but they don't cancel out the foreman yelling, hey, look out for the forklift. Right? Because like hearing protection, things like this, I can't hear the paper machine, that's good. I can't hear the beeping of the forklift, that's bad. Right? Whereas they can be more adaptive than that. These noise-canceling ones can
Good luck.
Yeah, go get them. Noise-canceling ones can be more selective about what they cancel and what they don't cancel. Okay?